Now we will draw a DAC. Here we have available plate of 10 mm thickness. Half of that has been welded, that is 5 mm welding is there, and 5 mm has a cavity. So that cavity will be considered as a defects, and we will take the 3 deflection according to the different beam path to get the different echo from different beam path. So according to the thickness and the available skip distance, we will take the 3 echo from the full V, 1.5 V and 2 V, and that 3 point will be considered as a 3 point of DAC, and that DAC can be using as a reference for the scanning of a plate which has a thickness of that same equivalently. Okay, we will start to draw the DAC. To draw the DAC, we will go to the range that we have a requirement of range. Here is only the 10 mm. So if we are calculated this, the maximum half beam path will come 14.4. So according to that, full beam path will be 28 point something. 1.5 beam path, that will be approximately 42, and full beam path, that will be approximately 40 plus 16, that is 66. So according to that, we are using the range here the 100. Velocity, that is meant to put 3250 transverse wave velocity, and the range gain whatever it is. Then we will put the values of the angle probe. So we are using here the 45 degree angle probe of 4 megahertz. So we will put the measurement is on, x of value 11 mm, angle that is 45 degree, and thickness of the plate is 10 mm. Now we will take the first point. We will go to the DAC menu, and now we will on it, and then DAC draw. So for the DAC drawing purposes, now we will use the echo from the full V. So we will place the probe according to the full skip, and the echo will come, that will be maximized. It will be at the 80%. The adjustment of the dB will be done such that the first echo will be not saturated, and it will be maximum 80 mm. If it is 80 mm, then we will gate it, and after the gating, if we are using the 0.1, then it will be considered as a 0.1, the first reflection into the full V. Now we have freeze it, and then we will take the second point at the full V. The first one, that was at the 1 and full V. Now it is at the 1.5 B. The echo is here at the 1.5 B. Whatever the maximized echo will be there. We cannot change that dB. It will become to the 40% approximately. We will take it in the 40%, 40 or whatever it is, whatever the echo will be there, it will match with the surface distance, and as well as the depth. The depth is 8.7, 5 plus capping that has been added, and now it will be considered as a 0.2, and we will enter it. So if we are unfreezed it and we select the 0.2, then 0.1 and 0.2 will be connected. So now we will use the same mechanism to take the third point from 2.5 beam path, and the third echo from the third beam path, that will be available here. We will get it, whatever the maximum height, that will be 20, 22 or 30% exactly, where it will match with the surface distance and depth depth is 0.5 because it is we are considering from the ID side, and now it will be selected as a third point. So this is the point 3. And we will select it. So a DAC card will be available at the 3-point DAC, first in the full beam path, second in 2.5, and third one is the third beam path. So this DAC we will save it. So we will go to the DAC menu and we will save it. When it is saved, then it will be saved into the memory. And now it has been saved. The DAC is there. If we want to see this DAC at the 6x14 range, then this DAC is the 100% DAC line. If we are using the 6x14 card, then 50% and 20% DAC line will be available according to our drawn DAC.